Hello, Algebra 2 students. Today we're going to look at completing the square and operating with square roots. So completing the square is like a fundamental procedure that you need to know if you're going to work with any kind of really non-basic parabolas or actually other conic sections like you'll be seeing in either this class or geometry. I'm talking about ellipses, hyperbolas, and circles. So completing the square is essential to understanding and working with any of those things. Even being able to transform them, you have to be able to complete the square. For us, it's going to achieve some more practical and immediate uses. We're going to be able to take parabolas that are in polynomial form and change them to transformation form. Transformation form is like one of the holy grails we have in this class so far. Transformation is the key to understanding what anything looks like, kind of, right? So that's one of the reasons we're going to learn how to complete the square, but very useful and versatile technique. Before we can complete the square, though, I thought we'd talk about something simpler. Let's talk about operating with square roots. I think this is something you should have done in Algebra 1. And it works exactly the same way as solving other kinds of equations. So, if you want to get x by itself here, think about it as what's in the way of x? The squared. So the only question is, what's the inverse operation of squared? What gets rid of squared? Square root gets rid of squared. Here's the key, though. If you solved this not with operating by square roots, if you solved it by factoring, I think this one factors pretty nicely. And some of these other ones factor nicely as well. I'm just showing you another way to do them today that helps us complete the square. So before we even do that, let's think about doing this abstractly. What squared gives you 49 abstractly? 7. Is 7 the only thing that will give you 49 when you square it? There's one other thing. Negative 7, because negative squared is positive. So we could just do that one in our head, really, right? Like that's called solving by inspection. Just looking at it and inspecting it and getting the answers, 7 and negative 7. So we could also do it with difference of squares, which, like we talked about a second ago, the first step when you're factoring is always to set it to 0. So you could go minus 49 on both sides, right? And that's definitely difference of squares. So you get x, 7, 7 minus plus. You set each factor to 0, and you get 7 and negative 7 that way, right? So we're pretty clear then that this parabola crosses the axis twice, right? At 7 and negative 7. So when you're operating with square roots and solving it that way, where's the plus or minus? You have to insert it. So the square root cancels squared, and you get x equals the square root of 49 is 7. It's not 7 and negative 7. You, as the mathematician, you, as the doctor of mathematics, have to deal with this side effect, which we're pretty clear about, right? Is that it's not just 7, it's negative 7. So every time in this chapter and any other place in mathematics, if you operate with a square root on an equation, on both sides, what do you always have to put? Plus or minus, right here. That act of operating introduces a side effect. Whether or not you want to deal with that side effect, you're a doctor, you've got to deal with it, okay? So now if you have a problem that already has a square root in it, does that mean you put a plus or minus in front of that artificially? No. If you put the square root in, you act on the equation. You have to put the plus or minus in, okay? So that's a big thing. People miss lots of points on my exams just from missing that plus or minus, and that's essential in parabolas. So watch out for that. Okay, these other two problems I think you can solve by operating with square roots as well. Can you guys help me? How do I solve this? Remember, operating by square roots, you're thinking just get x by itself, right? So the first step is subtract 11. It's just like when we did absolute value equations, and it's going to be like that for other equations we do this year. If you're trying to get x by itself, move stuff away from it. So we first get, what, 4x squared equals 48. Then, so you get x squared equals 12. Then, operating, side effect. You guys think I'm making a big deal about this, but I'm trying to get it stuck in your head. You gotta put that plus or minus. I'm trying. Okay, plus or minus the square root of 12 is the answer. I think we've already talked about at least once this year reducing square roots You always want to reduce square roots as much as you can. This one reduces. Square root of 7 is square root of 7. Square root of 13 is the square root of 13. Square root of 21 is the square root of 21, even though it factors to 7 times 3. But this one factors to 4 times 3, and 4 is a square number off your power table. This year, when we work with different kinds of roots, be they square roots or cube roots, if you can pull out power table numbers, you need to do that. So we're going to go plus or minus 4 times 3, which is plus or minus 2 roots of 3, or 2 times the square root of 3. People say it different ways. Okay, cool. We could turn that into a decimal. The decimal will be like what? 3.4. 3.4? 3 point something, right? Because square root of 9 is 3, and the square root of 16 is 4, so it's somewhere in the middle of those. Okay, we can use our calculator for that. Let's do the same thing on this one. This one's a little bit more challenging, and it should lead us to completing the square too. Because I can't just like solve for x. You guys know what I'm saying? Because there's one here, and it's being squared, and then there's another one that's not being squared here. But these don't share the x.
You can add the x to the other side.
So you've got to be a little more clever on this one. This is the key to the cleverness we're going to use in completing the square. Is that look at the left-hand side there. You should look at it and be like, man, that's pretty nice. Maybe not yet. Soon you're going to be though. Like I look at the left side and I'm like, wow, that parabola, it's got curves. It's pretty nice. You know what I'm saying? I don't know if you guys know what I'm saying. I'm not even looking at the 27. So you can factor stuff without it being set to 0. The 0 thing is just like let's let you find the zeros at the end. That one factors pretty nicely, doesn't it? How's a factor? I hear people saying it, they're just all quiet. Like Mr. McGee is way too excited about this parabola. Why am I saying this one is so nice? I mean, lots of parabolas factor.
This one factors into the same number, and it's a nice number that's easy to multiply by.
Yeah. It's because this is a perfect parabola. It's a perfect trinomial. At least on that side it is. See, and now, since it's perfect, I can write that repeated factor with what's called a multiplicity of 2. Probably haven't heard that word yet, but that's how you say this. And why is that nice for operating with square roots? Can you guys help me? Because now to get rid of squared, you just do that, right? We couldn't do that before. If you tried to square root this before, it wouldn't cancel because there's all kinds of other stuff blocking it up. And when I see this kind of thing on papers, oh man, it just like, it makes me sad about my life. It really does. Like that shows me that you haven't learned anything about parabolas. So be careful with that. Because like, the point of doing the square root here is to cancel, right? But these completely prevent that cancellation. It's not like you could distribute the square root. Square roots don't do that. We're going to learn more about them next semester. You should never, I should have never even written that down on the board so that you never even considered it. I'm sorry. I'm sorry, I apologize. Okay, so going back to this. This we can square root. Side effect. So now we've got x minus 5 plus or minus the square root of 27. 27 simplify. Remember, sometimes they don't. This one does. 3 and 9. 9's a square number. So that's 3 square root of 3, yes. Okay. I haven't gotten x by itself though until I add the 5. I'm going to show my work just to make this nice and clear. So I'm going to get x equals 5 plus or minus 3 roots of 3. And we can turn that into a decimal, but exact answers are better than decimals. So. Okay. So that's all kind of like Algebra 1. I know that we did most of that in my Algebra 1 class, about all of it actually. Let's take this up a notch because we wanted to complete the square today, and that's where we're really trying to go. So it all goes back to this part. Okay, that part. That's the key. You guys got it? Okay, so let's start out with a couple simple problems. What if we have this? I don't know, let's go. Let's go for this. Let's go for this. Let me look at my notes, see what I've got hooked up in let's do this one. So before we even do the full process and see what we're using this for, I just want to complete some squares. You guys know what I'm saying? So each one of these trinomials, in fact, are they trinomials yet? They're just binomials right now. So each one of these aspires to be a trinomial, and it's aspiring to be a perfect trinomial. And we're going to make that happen. We're going to make these binomials' dreams come true. Okay? So we're going to do that by completing the square. So the only question is, what magical thing do we have to add to make these perfect? Each one has a special magical thing that we need to add. I'm going to add that right here. What do I need to add to this first one to make it perfect? Who knows? I, of course, am going to tell you how to do it in a second, but I want to see. Can anybody do it? Josh, did you have an idea? No? 49? Anybody else? Does that sound like a good idea? Kyle? You say 0? Okay. Richard, do you have an idea? 7. Oh, that's a good idea too. Josh's idea is correct. 49 is the magic that makes this binomials turn it into a perfect trinomial. The only question is, you don't want to have to be that clever every time. Josh was pretty clever there. How do you get 49? And the reason it works now is this, right? Like, how's that factor now? And you don't even really have to write this down. If you did it the right way, you should just be able to go straight from there to x plus 7 quantity squared. That's the whole point of what we're doing here, so that it'll do that, right? How did he come up with that, though, Richard?
I was also wondering, would you have been able to get it without doing the 49 and just end up with x plus 2, x plus 7?
No, you'd have to do what Josh did, I think. The question is, how do we avoid having to be that clever for every problem? Because it's much tougher on that third one. Here's the idea. To complete the square, the magic that you're going to add, so the added magic, which was 49 on this one, is you take b, because b is the coefficient on x in parabolas, you cut that in half, and you square the result. 14 cut in half is 7. 7 squared is 49. So can you guys tell me, what magic am I going to add to make this guy perfect? 144? So I cut this in half, that's negative 12. Negative 12 squared is 144. That's what's going to make that perfect. And since it's perfect, I don't even have to write this step down. I can just say that's equal to what quantity squared? X minus 12 quantity squared is that. If you don't believe it, write it twice, spoil it, you'll see it is. And it's important at the beginning here, if you don't really believe that, you should expand a couple of them out and make sure for yourself. So this one's a little tougher to do, like just guess the number, but who can tell me what is it going to be? I'll give you a second. Think about it. What magic am I adding here to make this perfect? Just follow the process. What are we supposed to cut in half?
9 to get rid of
And then we're supposed to do what with that? Fractions aren't hard to square. It's not a nice number, but
25.
that's it. This is not a hard fraction problem. I didn't think that was hard, did you guys? Like square the top, square the bottom, okay. That's the magical thing you need to put here. And then you know, just because of the magic of completing the square, that this guy is going to work out if I go x plus 9 over 2 squared. Now that one's a little harder to believe, right? So maybe we should multiply it out and check. I'm going to do it really quick. So is this guy truly that guy? Let's find out. These are like terms. 9 halves is 4.5. What's 4.5 plus 4.5? It worked. It was made to work all along, so it shouldn't be a surprise to you. So there's how you complete the square. How you, like I like to say, add the magic. Let's see a little bit where we're going to use it. So we're just going to use it today to solve a couple equations. Tomorrow we'll look at finding transformation form. We'll just solve these and call it a day. Now you might be able to solve these problems another way. In fact, you definitely can solve them other ways, but we're learning to complete the square. So. Well, the first step is usually do what? You're solving something like this, you guys already know the first step is like 0 or 0. Yeah. So I'm going to do that. I'm going to say x squared minus 12x. And then I'm going to leave some space. Set it to 0. Why do you think I left that space? Just for the magic. Magic. What am I adding? Yep. Cameron.
Wouldn't it be positive 26 and then
Yeah. Thanks. Plus 36, right? Because half this is negative 6. Negative 6 squared is 36. That's the magic. Okay, but now we're like in an equation, right? We aren't just like in the magical place we were a second ago. So like, can I just like put plus 36 on an equation like that and have it be the same? I don't think I can do that. So like, how can I compensate? There's a few ways. Josh's way is he said put it on the other side. He's right, you can do that. Do something to one side. Got to do it to the other side. It's just the something we're doing is a little more clever than what you're used to. Okay. You could have also just subtracted it on this side, right? And that would have compensated as well. So why did we do that? We did that because now this part right here is perfect. It's x minus 6 quantity squared, in fact. And then I just got some other numbers, so collect them, see what happens. This is what, 56? Kyle?
Isn't it just 20? Because the plus 36 is in your square.
Okay, very nice. I was wondering if anybody was going to catch that. Should I have had 56 there? Did I use all of this to make this? So I should just have 20. Very good. You guys are getting it already. So. And now it's one of those problems we just did a second ago, right? Solve for x. Minus 20, get x by itself, and you're done. 16, square root on both sides. You can show it or not. What's the square root of 16? 4, so we have x minus 6 equals 4. Add 6 to both sides, and you get 10. Oh, God. Jeez. It's the danger of not showing this. I missed my side effect. So really, this is one of my answers, right? Then I've also got x minus 6 equals negative 4, so I've got to go and get the other answer is 2. Okay? Let's do it with the other one. So I'm going to turn it around, get it in good shape. I could subtract this and set it to 0, but if you saw on that last problem, that was kind of a waste of time. This one's got something that's key, and this is going to make a lot of people mess up if they don't practice thoroughly in their homework. This 3 screwed us up in factor land, right? Well, it's going to mess you up here too if you don't account for it. So like in factoring land, didn't we usually like want to try to divide it out? You could do that. I think it would divide out here, but some problems it won't. So pull it out. That's another way to say divide. So you're going to have x squared plus what then? 6x. If you try to complete the square without accounting for that, you'll be wrong. So careful. Now complete the square. What magic do I need to add? 9. Now we've got to compensate to balance the equation so that we didn't just add arbitrary junk, because we can never do that in algebra. So somebody carefully tell me how I'm going to compensate here.
Have 3 of those.
I guess you're Richard. You said we don't have just one green 9. This guy's distributing to it, isn't it? We really have 3 green 9s. In other words, what do we actually put on this side? We actually put 27 on this side, so we better put 27 on the other side too. That gets a lot of people, and this is very important, I will tell you, for advanced math. Quite important right here. One of the tougher things we'll do this whole year, though, I think. You'll see. 45 and 27 then is going to be 60 plus 12, 72. What's this guy compact down to or condense down into from our perfect process we've been learning? A lot of the time people will say compact right here. X plus 3 quantity squared. And now it's an easy question. Solve for x. First step is divide by 3. I'm going to show my work just to make sure this is clear. Divide by that 3. Square root, plus or minus. So we're going to get x plus 3 equals the square root of 24, and x plus 3 equals the negative square root of 24. Does 24 do the simplify thing? Can we reduce that radical? Does it have 4 in it? Does it have 9 in it? Does it have 16 in it? Does it have 25 in it? It has 4 in it. Oops. Oh man. So this says x plus 3 equals 2 root 6 minus 3 minus 3. There's one of the answers. This, by the way, we couldn't have done this problem factoring. It's impossible. Well, I shouldn't say impossible, but well beyond the scope of our course. So then we've got minus 3. Oh, man. Just can't stop making mistakes today. And there's our other answer. The only other way we could do that so far is to use our calculator. And it wouldn't give us those, still would just give us these big yucky looking decimals. Yeah?
Would have been much easier. I know it wouldn't have showed everybody how to do the rest of that, but so we just divided the whole thing by 3.
Yes, very smart. And I mentioned that kind of just barely, but I was too fast. James is very correct, right? Could we have divided everything by 3 and not worried about this 3 the whole time? Yes, sir. It's a very good comment. Would that have been the smartest way to do this problem? Yes.
Just roll.
It would have been a lot faster. I just wanted to show you how to compensate by a 3 like this, because sometimes you can't do that. What if I did this to this problem?
I see about
44 is not divisible by 3.
So we need to take.
And you can still do that problem this way. It'll just be even uglier than what I showed you. So I barely changed it, right? Very good question. Very good. All right. See you next time.